Hello and welcome. Hello and welcome to Chapter 1, the modes and equations. The same way everybody didn't like states of matter and felt that it is a difficult chapter to revise, it's very easy to revise. Here, sometimes this happens with Chapter 1, but the information in Chapter 1 here in the AS is a lot. So you need to know that information and you need to quiz yourself in it to make sure that you know it. So let's start, and our source today is k-chemistry.com, the website where you find all this material that I'm explaining from. So let's start with lesson 1, the structure of an atom. We'll deal as if we don't know anything here. Welcome back. So today we are diving into the heart of matter to understand the structure of an atom, and let's get started. Matter, as we know it, is composed of small atoms. Actually, it's not small. It is the smallest particle of an element capable of engaging in a chemical reaction. The core of an atom is a very, very small, dense nucleus, which is surrounded by a large area of mostly empty space. As we explained earlier, that the nucleus, when compared to the size of atom, is very small. Right? When you are comparing a stadium to one person inside the stadium holding a raisin in his hand. So if you compare the raisin size to the stadium size, this is how you can compare the nucleus size compared to the stadium size. So you can imagine how the nucleus is very small compared to the atom and how much there is big space in between this raisin and the whole border of the atom, if there is a border, which there isn't. So we can say that the core of atom is very small and it's made mainly of four things. The nucleus, which contains the protons and the neutrons. So if we imagine that there is a nucleus here, this is our nucleus. What does it contain inside? It contains inside the protons. I know that all of you know that very well. And also contains the neutrons. So since the protons are positive and the neutrons are neutral, we all know that this makes the total charge of the nucleus as a positively charged. The protons are the particles which carry the positive charge, while the neutrons are the particles which carry the zero or the no charge. What about the electrons? As we know, the electrons are the negatively charged particles that reside in orbitals around the nucleus. Remember that the diagram of atom is not to scale, so the nucleus is much smaller compared to the overall size of the atom, as we explained. All these particles, protons, neutrons, and electrons, are called the subatomic particles. Their masses and charges are usually relative and not actual charges and masses. We'll say that the protons and neutrons, they both have very small mass. We assign them a relative mass of 1. We're going to explain this now. What about the electrons? They are very, very, very tiny. So if you compare their masses to the protons and neutrons, there will be 1 over 1836. That's 1 over 1836 times smaller. And what about their charge? If the charge here is assigned positive and this is assigned neutral, this is assigned negative. So we can compare this in a table, the subatomic particle, its relative charge, its location, and its relative mass. If you want to know what is the relative mass, you can imagine an elephant here. So this elephant name, we will call it a proton. And then we will imagine a rhino. So this is a rhino, and we will call it a neutron. Then a tiny, agile mouse, we'll call this mouse the electron. These three are the heart and soul of our extraordinary molecular surface. Much like the protons, neutrons, and electrons being the star performance in the grand show of an atom. So just like we have in any circus, it's important to know our performance, talents, and traits. But we cannot use the conventional tools. What if I asked you what is the way of these people, the elephant, the rhino, and the mouse compared to a feather? In a feather scale, you cannot compare or weigh these animals. Why is that? Because it's not just not accurate enough. It is that the small particles are very, very tiny. We measure them using the everyday units like the grams or the coulombs for the charge. So to bypass this problem, we dive into the world of relatives. What is the world of relatives? Imagine if we said that compared to the elephant, the rhino weighs the same, but the mouse is much, much, much lighter. So here we are not speaking about the weight in pounds or kilograms. We are just comparing them to each other. In the same matter, we can compare the mass of a proton and we'll say that this is the standard. This is like our elephant. And given a relative mass of 1, the neutron also weighs as much as the proton. That's our rhino, so it has a relative mass of 1. While the tiny mouse, which is our electron in our example here, is much, much lighter. So we'll give it a mass of 1836. That's compared to the proton and neutron, our rhino and elephant. So as just like our performance here have different weights, also they have different charges. The proton, the positive element, has a charge of +1. Again, compared to the coulombs, that's nothing. It's just a relative number. While the neutron has a 0 charge. It's a neutral rhino. And the electron is a negative charged mass, so it's a -1. So remember, these relative masses and charges are like comparisons, not actual masses or charges. It's like comparing our elephant, rhino, and mouse in our molecular surface. We have some atomic key terms to explain. There are few terms that you need to know to understand the structure of an atom. The atomic number. What is the atomic number, or the Z? It's the number of the protons in the nucleus of an atom. In a neutral atom, the atomic number is also equal to the number of electrons. What about the mass number? The mass number, or E, is the total number of protons plus the number of neutrons. And you remember from the last year, we used to call these particles the nucleons because they are found inside the nucleus. The number of the neutrons can be calculated by just subtracting the atomic number from the mass number. You will get the number of the neutrons. So I know that was easy. I know that you know it already, but you have to make sure that you know it, because it will be very bad if a question about these small, simple concepts come in the exam and you fail it. You don't want this to happen. So let's see the next lesson with some of the questions about that.